Hey everybody, in this video we're talking about temperature-dependent spontaneity. Let's take a look at this reaction that forms carbon dioxide gas. We know the delta H and I can see that it's negative. That's going to be an important detail. We know the delta S. I can see that it's also negative. Let's try to figure out, is this reaction enthalpy favored, entropy favored, both, neither, and what temperature range is required to get it to be favorable? Let's first recap what we mean by favorable in the first place in terms of thermodynamics. This means one thing and one thing only. The reaction has what's called a negative delta G value. The free energy change is negative, which means free energy is released. All reactions that are favorable have to have that being true. In terms of delta H and delta S, that also means there's certain sign conventions that are going to go along with that. For enthalpy, we need reactions to release heat to make this possible. So negative delta H's help the delta G to be negative, so that's called enthalpy favored anytime it's negative. In terms of entropy, you want the products to have more entropy than the reactants. That's a positive delta S sign. That's going to help the delta G to be negative as well. So if your reaction has a positive delta S, that's called entropy favored. Let's label both of those for our reference. So there we go, I've got my labels in there, and now I can apply that to the specific reaction we're looking at here. I can see that in this equation the delta H is negative. That means it releases heat, and that means that the reaction is enthalpy favored. So I can label that here. Next, if I look at the delta S, I can see that its sign is negative. That means the products actually have less entropy than the reactants, and that's not good for being a favorable reaction. So this is not favored by entropy. So we can label this as enthalpy favored only. Next thing I'm going to do is try to figure out the exact temperature range where favorability occurs. To do that, we have to use the equation delta G equals delta H minus T delta S. Now with this equation, there's some scenarios where there really isn't a temperature range, or at least the temperature range would be something like all temperatures. That's going to happen when the reaction you're analyzing is both enthalpy favored, so negative delta H, and entropy favored, so positive delta S. With those signs, a negative H and a positive S, your answer for delta G will always be negative. If you just think about that, a negative minus a positive, you are guaranteed to get a negative delta G as the answer, no matter what this temperature is. Big number, small number, it makes no difference. So for a reaction like this, with a negative H and a positive S, you could say that the temperature range is literally all temperatures, because it doesn't matter what the T is, it's always going to have that negative delta G. One thing I want to back up and clarify is the temperature value I have filled in as positive. That's because these temperatures are always reported in Kelvin, and Kelvin is unique in that they're always positive. The bottom of that scale is 0, which means you can never have a negative Kelvin temperature. So let's jump back then and try to do a similar thing for this specific reaction, where I don't have to just imagine plugging in negatives and positives. I can plug in real numbers, like for the delta H, negative 283, minus the T that I'm going to leave as the letter T, because that's what I'm going to be solving for to find the exact temperature range, and the delta S gets plugged in as negative 0.0865. Notice how I switched it from 86 to 0.086 to turn joules into kilojoules, so that my two energy units match here for the things getting plugged in. The other thing I'm going to do is plug in 0 for the delta G, and 0 is a helpful value to use because that's the exact point when the delta G switches from negative to positive, or when the reaction switches from being favorable to non-favorable, and it's really what I'm interested in here when it comes to the temperature we're solving for. At this point, we've just got to do the algebra to solve for the temperature when this happens. And that comes out to 3,270, let's just round this off to 72. The unit there would be Kelvin. So I know that something happens at 3,272 Kelvin. That's when it switches from being spontaneous or not spontaneous, favorable to not favorable, negative delta G to positive delta G. The only thing we haven't clarified is to be specifically favorable, so specifically to get a negative delta G. Do I want the temperature higher than 3,272 or lower than 3,272? That's the last thing we've got to figure out. And to do it, I'm going to go back to this equation one last time and just rewrite it in a slightly different way to make this easier to see. My delta H is still negative 283. But here, because this is a minus and this whole term is negative, those two negatives are going to cancel out. I'm instead just going to write this like this. Negative 283 plus that T times the 0.0865 delta S. And that's just going to make this a little bit easier to think about in terms of how this T delta S is going to change this negative 283 to give me that delta G. Now remember, to be favorable, we need the delta G to be negative. So you got to think about what sorts of temperatures, high temperatures or low temperatures, are going to allow this delta G value to be negative. And it's all based on the fact that the delta H value is already negative. And because the delta H is already negative, I need to keep this T delta S term small, at least smaller than 283. Because if T delta S became larger than 283, that's going to start giving me positive answers for my delta G, and that's not favorable. But if I could keep my temperature small and keep the whole T delta S term small, at least smaller than 283, then my answer will remain negative for delta G and the reaction will remain favorable. Since I've established that I need to keep the T delta S term smaller than negative 283, that means I need to keep the temperatures low, and I can say that at temperatures less than 3,272 Kelvin, my delta G will be negative, which means my reaction will be favorable, and I've established the temperature range required for favorability. That wraps it up for this video. Thanks a lot for watching.